So I'm a research scientist that uses predominantly kind of high-resolution computer weather models to understand what intense precipitation events can look like. So water managers in general are interested in extreme precipitation. The folks that I work with here at Reclamation are tasked with doing a number of different types of studies, dam safety studies and hydrologic hazard assessments. And one of the biggest questions that you try and answer in those types of studies is how hard can it rain over a given period of time, over a given area. You know, when you build something like a dam to certain specifications, you need to know how hard it can rain at a given location, you know, how strong things need to be and so forth. So there's a big need to know what extremes can look like for a given place. The folks here at Reclamation are tasked with an inordinate amount of effort to come up with probability curves and frequency curves and how much rain can fall and when. And a lot of that's statistically based. And so a lot of what I do kind of provides a complementary sort of puzzle piece to that and saying, you know, it's not just teasing out the known data that we have, but here's an actual picture, a snapshot of how rain can fall in a physically realistic, real world kind of framework. What I use as my sort of meteorological toolbox is a computer weather model, so kind of like the forecast models that you do see on TV. We use tools like that to model storms in high enough resolution, and hopefully they look enough like what can really happen in reality that water resources managers can use that information and say, you know, we might not have the best data set in the past, but we think this looks like what could have happened, and so we can use this information instead. In terms of really understanding what the event looked like, it's been a ton of guesswork in the past that went into it. Which creeks overflowed, you know, how high they got. So there's a lot of sort of forensic detective work that can go on after the event. And then even once you have all the data, getting all the research done, there's definitely years of that to come. And what I've learned from working with these guys is actually that it's just as big of a question what the events have looked like in the past. You know, we might know something about an event that happened in the 1970s, but you might only have one measurement taken from a horse trough in, you know, the middle of the mountains. So in September of this year, about 4 months ago, Boulder witnessed some of the most severe flooding we think we've had in maybe centuries. So extreme precipitation fell in Boulder, and that ended up being about 18 inches of rain over the course of about a week. That was a recent and rare example of getting over 1.5 feet of rain in a place that is really usually pretty dry in September. This was an event that happened in recent enough times and in a populated enough place that we have an extremely rich data set that we can now use. Less hand waving, less guesswork as to what happened in past events, so a lot of ground truth. As a meteorologist, you like the weather, and so of course getting to study things like extreme precipitation is fun. You know, when I first came here as a postdoc, when I first discovered working with Reclamation, it's really appealing to know that people have a need for your work and that it will be applied somehow. It's more rewarding than simply publishing a paper at the end of a study.